Alright guys, well today we're going to do problem 2028, find missing observations. This is the Leetcode Daily on Thursday, September 5th, 2024. And it's a very rare occurrence. It's a very rare observation. It's a problem I've never done, okay? Haven't read it yet, and I thought maybe it'd be just a good idea to go through this in real time and see if we can figure out how this is supposed to be solved. Okay, so, already looks like it's going to be hard just by reading the first sentence. Okay, so you have observations of n plus m, six-sided dice rolls with each face numbered from 1 to 6. Okay, so it's like a normal dice has 6 sides. N of the observations went missing, and you only have the observations of m rolls. Okay, so the total number of rolls is n plus m, and you know the m rolls. All right. We've also calculated the average value of the n plus m rolls, right? So you have the value of the mean, right? It's given here as mean, and the mean is equal to n plus m over, well, something. What are the total number of rolls? But that would just be 1. But the actual value of these rolls. So the value of n plus the value of m, I guess. Value meaning the actual sum of those rolls divided by, let's call it n plus m to keep it simple. Okay, that's how you calculate averages. You're given an integer array rolls of length m, where rolls I is the value of the ith observation. You're also given the two integers mean and n. Okay, so what do we know in this equation? We know the number of rolls n that went missing. We know m, that's just the length of rolls. Okay. And we know the mean. Return an array of length n containing the missing observations such that the average value of n plus m rolls is exactly mean. If there are multiple valid answers, return any of them. If there's no such array exists, return an empty array. The average value of a set of k numbers is the sum divided by k. Yeah. We know how to. I hope we know how to do averages. Note the mean is an integer, so the sum of n plus m should be divisible by n plus m. All right, so it has to be divisible. All right, 10 to the 5. Yeah, of course the mean is going to be between the maximum value and the minimum value. How do we go about this? Okay, so we know that there's 2 rolls missing, and the mean needs to be 4. Okay, so we know from this problem, right, that 3, I'm just thinking about this, right, 3 plus 2 plus 4 plus 3 plus the 2 values that are missing divided by x is the value of n1 plus n2. I'm going to say these are the 2 values that we haven't accounted for yet. This is like more of a math problem than a coding problem, which is kind of annoying. But, you know, this is, I guess, if they want to test your just kind of your IQ and your base math knowledge, is the kind of thing they ask you. But this isn't really like a data structure or an algorithm problem. This is you like, can you do math and try to, you know, work numbers to figure out how you're going to do this. So there's m is 4, n is 2, so divided by 6 has to equal the mean, which is 4. Okay. So, all right, well, there's going to be some math in here because you have to figure out how you're going to get, because we can figure out x here pretty easily, right? We just say x equals 4 times 6 minus this whole sum. Did I do that math right? So I multiply both sides by 6 to get 4 times 6. And then I have x and these things alone, and then I subtract this from both sides to get this. So this in a general formula, right? Like the value that's missing is, how did I get 4 here? Here, this is the mean. How did I get 6 here? 6 here is n plus m. Sorry, I'm just trying to take what I just did and put it in a general equation so we can think about how do we get the general value every time. Okay, so that's n plus m. Minus the sum of rolls, right? So basically, if I want to figure out what's missing, I just do this equation, right? I take the mean value, I figure out what n plus m are, which are given, and then I subtract in the sum of the rolls, and that's what's missing from this equation, right? So in this equation, what's missing? It's 4 times 6 is 24, minus 4 is 20, minus 3 is 17, 15, 12. So x is 12. And I need to be able to get 12 in 2 rolls. And to get 12 in 2 rolls, you get 6 and 6. So that's how this works, right? So there's kind of 2 parts to this problem, right? The first part is use the equation to figure out what n needs to sum to, right? And then we'll call that big value x, right? And that means that the sum of the n rolls needs to equal x. So then we need, for the second part, how are we going to find those rolls? Okay. Now I'm kind of curious about the second part here. So let's just figure out this. Let's do this first part first. So let's do this first part first. I'll keep this all commented out. I don't know how Python feels about comments that are like that. So let's put it in the same indentation. And then we'll just say, what will we say here? We'll say that, you know, n equals, we already have n. M is the length of rolls. Do we have all the other values here, right? We already given n, we have mean, we have rolls. So that's your x value, right? So that's just the first part here, your x value. Now we need to figure out how can we generate these different rolls using the number of values that we have, right? So that's actually where this problem gets hard and where there might actually be data structures and algorithms involved, right? Because here, for example, you can see it's a lot longer. Why? Well, you know, let's just run this one through because I don't feel like doing the math right now, right? But if I take 1, 5, 6, 3, and 4, for example, I'm going to print x here. I'm going to return, I don't know. It's not going to return the right thing, but I'm literally just, you know, trying to get something out here. Okay, so 9. So we're missing 9 here, right? 3, 4, 5, 6, 7, 8, 9. But I need to make 9 with 4 values. All right, so that's where this gets kind of hard because I have 4 values to make 9. So how are we going to do this efficiently? No, that's not going to work. All right, I'm thinking about how to do this efficiently. I need to make that value using what I got. Something's telling me like, well, problem is it's too slow like this, right? But yeah, too slow like what? I'm not talking. You know, they all, like, I know I have missing values, so I know they should all be at least 1 in the beginning, right? And I look at this value and say, okay, the value here is 4. I need my value to be 9. So I'm still below the minimum. So if I could say, okay, what's the next largest value I can get to? I double it again, I get to 8. 1, 2, 3, 4. Now I have 8. And I say, okay, if I double them all again, how much more can I get if I make them increase one more time? Make this one 3. Only one of them needs to be changed to make that 3. 3, 2, 2, 2. All right. So I need to do a way to do that efficiently because I don't want to be writing over all these things over and over again. So I need to think of a way of how am I going to generate this thing simply. And I have some ugly ideas here. Right, but if I keep track of all the counts that I have of everything, right? So these will be the missing dice, but I'll put it in this this thing, and I'll say, well, n is the number that I'm doing, right? So they have to all be at least 1. Writing the code for this is actually what's hard. Okay, die. That was an accident. 4, because if you're 1 off, right? This is funny. So FOR, if you go 1 left on every character, it's DIE, die. Just a little weird side note for you. Okay, so how are we gonna do this? Our sum is initially 0. We'll say while sum is less than what I need my value to be, which is x. I'll say if sum plus n is less than, all right, we'll do current die value. A lot of these things might change a lot here, okay? Current die value is 1. We say while current is less than x, say current die value plus equal 1, sum plus equal n. Yeah, but will there ever be a case where you need to like oh man, this is hard. Hard medium. Especially because I didn't even notice this. There's cases where it doesn't work out, but I won't worry about that right now. But, you know, we'll just say do. So I'm trying to think about invariance here. I apologize, guys. We're just going to try this, and if it doesn't work out, it doesn't work out, and I'll have to think about something else. But this is the idea that I have right now. So, let's see pre-sent die and our S value. I'm trying to get an idea of if this code will do what I need it to do. Oh, shit. So 3 and 8. And what do I need it to be? I need my value to be, so I got, if I use just 2s, I can get to 3. What's the difference? The difference would be the remainder. All right, I think I might be able to explain this. You say, okay. C die times S x minus S plus C die times C die plus 1. Wait. N minus x minus S. That's the difference. X minus S. You're looking at me right now like, what the heck are you even doing? I don't know. Just 4. Okay, N in this example is 4. My C day value becomes 3. This is minus x minus S like this. not explaining things at all here, and I apologize, guys, but I will in a second. Let me just see if this theory works out. All right. C die minus 1, because C die gets increased. All right. Let's say if C die is greater than or equal to 6, or greater than 6. No, greater than 7, I guess. Return this because it's impossible. Greater than or equal to 7. I'm really just brute forcing this to try to figure out different situations where this doesn't work. All these cases where it doesn't work out, I need to figure this out right now. That's the problem. So let me just think about the cases where it doesn't work. So let's go with the first one where it doesn't work, because I'm trying to brute force in the basic idea here. But okay, 9, 9, 9, 10. Why doesn't this work? Because I need the sum to be, I say, so basically if the number that I need, if x is less than the minimum number that it can be, which is literally just n because they're all ones, or if the number is greater than n times 6, so they're all 6s, then it just can never work. That's kind of like the general case here, right? All right, cool. So let's go through what the actual solution is here, because I was just thinking it through. So the first thing here, right, is that, all right, the first part and the second part, I hope that makes sense, right? You can figure out what this x value needs to be for the mean by just, you know, doing the calculation, right? Like saying, okay, we know that the average of something is, or the mean, right, using the code words here, is, well, the roles of m plus the roles of n divided by m plus n, right? Because this would be the sum of all the values divided by the number of values. That's how you get the average, right? If you want the average height, you take the sum of everyone's height, and then you divide it by the number of people that there are, right? That's the same thing here. Okay, so in this equation, what do we know? Well, we know the mean, we know n, and we know the roles of m, right? I'll just call it roles here because it's called roles here for m. And it's not roles, but it's the sum of the roles, right? And this would be the sum of the roles of n. So what we do to figure out, okay, well, we need to know what the sum of the roles of n are to figure out what we need n to be, right? So to do that, we just do a little calculation here, right? So we divide both sides by m plus n, and that equals this. We can remove those. And then what we're solving for is the roles of n, so then we just subtract that thing from the other side. So that equals the mean. Why did I divide here? I'm an idiot. This is divided by. I apologize. So this is multiply. So mean times n plus m, right? Just moving this. They're just switching the sides here. Minus the sum of the roles. Right? So that's how we get this equation here. Okay, now that I have that value, right, what I basically know is, okay, I have this value x, which is the sum of the roles of n. And then I have n roles, right? So that means there's like n spots in here, right? Where this is n1 role value, n2 role value, n3 role value, all the way 2, n. Okay. Now the first question I asked to figure out if this can even be done is asking myself, well, if I have to roll n dice and the value, what's the minimum? Like if I have this value x, right? If I roll n dice, what's the minimum value I can get? They're all ones, right? Which is just equal to n, right? The sum of n is then just equal to n as a consequence, right? If they're all ones, that's the minimum roll I can do, right? The minimum roll I can do is I only roll ones. So if the value that I need is less than that, there's no way I can achieve it, right? If you're asking me, hey, roll 4 dice and I need the value to be 3. It's like, you need the value to be 3 and you want me to roll the dice 4 times? Okay, well, I can give you 1, then a 1, then a 1, then a 1. That's as small as I can go, which is 4. And you're going to say, no, but I need the value to be 3. Well, it's impossible. That's this case here. Okay? The other case is if the value needs to be like 30, right? I'd say, okay, you want the value to be really large, right? You need the n roll values to be really large. So I'm going to make this thing as large as possible. I'll do 6, 6, 6, and then a 6. So that's 24, right? So the largest I can do by rolling 4 dice with crazy low probability odds, right? 1 over 6 to the 4, is that I just keep rolling 6s, right? And that gets me only to 24, so I can't do 30, right? So the smallest thing I can roll is just n, where they're all 1s, and the largest thing I can roll is n times 6, where they're all 6s. And if that doesn't get me to the value that you need, right? If the value you want is smaller than the minimum thing I can do, or the value you want is larger than the maximum thing I can do, well, there's nothing in that I can do, right? So I just return an empty system here, okay? So this would be, you know, the minimum here. Okay, the maximum, like I said, is where they're all 6s. Which is the sum, so then the sum of n in that case would be 6 times n, right? So that's the range of value you can get, right? The minimum value you get is n, the maximum value you can get is 6n, and then you can tweak the values in between, okay? Now, that's how you can address these things. So that before I was like trying to figure out different edge cases, but really, this is the lesson here is, right, don't play that like submit game. Actually try to figure out, like, okay, what's the equation here? Because there's all these weird like edge cases. I wasn't thinking about doing it the way that I was doing it, right? Which is, it makes more sense to actually look at the math and say, okay, according to the math, these are the minimum things I can do. These are the maximum things I can do. And we have to live with those consequences. Okay. Now this weird thing here, what's going on? Okay. What I'm basically doing is I'm incrementing this array 1 by 1, right? Because the theory that I was working with, which is true, is, you know, if I have any value, right, like this, where let's just say we have a bunch of different values, right? A, B, C, D, E, F. If I'm trying to get to some value X, right? If you had an array, okay, let's say that the value was, I need it to be 7 for 3 rolls, right? You might say, okay, I'll do 5, 1, and a 1, okay? But what my code does to make this work and to find this array easier is to say, well, to get to 7, 5 to 1 to 1 is the same thing as, well, I can take this 5 and instead roll a 4 and make this a 2, or I could roll a 3 and make this a 2, right? And get it to 7 that way. So whatever value you have, right, if it's like all scattered all over the place, right? Like if this is 8 and you have 6, 1, 1, right? Or 5, 1, 2. The rolls, there's multiple rolls that'll get you to 8. And there's a systemic way of finding the roll, right? Systematic. Went to Berkeley, systemic. There's a systematic way of getting to 8 that doesn't include picking like things that seem random, right? So instead what you can do is you can say, you know, 5, 1, 2, well, what if I try to keep them as close together? So if I made this 4, 2, 2, or 3, 3, 2, that's also 8, right? So any roll that I can get, I can take one and move it over. So why does that help me? Well, then I can kind of systematically do this by starting them all at 1, right, at my minimum roll, and saying, does that equal 8? No, that equals 3 times n times 1. Okay? And then I can say, well, what if I make it larger again? So I'll do, what if I make them all equal to 2? Well, now that equals 3 times n. Wait, why did I do 3 times n? So that's 3n times 1. And I'd say, okay, what's n times 2? Okay? And I'd say n times 2 is, n is 3, so that's 6, so I'm still under. But then if I'd make it 3, make them all 3, that's n times 3, which equals 9, so I went too large, right? So I'd stop here and say, okay, if I make them all 2, I get close to the end. So then how many more will I have to increment to get to 8? Well, I can increment the remaining 2 one time. One time. Okay, so to make this, I'll just do a random example here. And I need to be equal to 18, okay? And I know it's possible because I can get to 18, which is 3 with 3 sixes, okay? So in the beginning, I need it to be equal to 18. That's my goal, okay? So we'll just walk through a simulation here. It's like, remember, the idea here was that if you have any values, like any value you get one place, if it's also like different rolls, you can get the same thing if you just decrease everything, make them the same, and then increment up. So if I need to get to 18, I'd say, instead of incrementing this array, I'd say, well, initially I have 5 elements here, right? So n equals 5. I'd say, okay, what if I made them all 1? I would get 5. It's too small. What if I made them all 2? I'd get 10. Still too small. What if I made them all 3? I get 15. Okay, it's still too small. What if I made them all 4? I get 20. Too big. So then I know, okay, I should make them all 5. Or no, I should make all the values 3. So then I have 5 values. So I get 1, 2, 3, 4, 5. But I'm still off by what? I have 15 here, but I need 18. So that means I need 18 minus 15 remaining. That's 3. So that means I should increase 3 of them one time. So this instead of 3 is 4, 3 is 4, 3 is 4. And do I get the sum 18? 12, 15, 18. So that's basically the idea. I just walk up, get to the point where I go over and I say, okay, go back 1, make all the values that, and then whatever the difference is, just sprinkle that in at the end. Okay, so that means that I can actually probably, this is actually probably kind of slow, right? My CDI value is just, that's why I'm walking through here. So I'm going to just call it die value is what? I had 18 here. So I'm actually going to make this more efficient here. So this is n times the die value. So my die value is floor divide 18 by n. Okay. So I don't even need to do this while loop, but just make this faster. Die equals 18. X, that's the value that you want, divided by n. Right? So now it's a little bit different because things can get a little weird when you're doing division and, well, yeah, it has to be. So I would say, okay, all of them will be the die value, right? Except for the number of them that didn't meet the cut. So that would be x minus n minus x minus die times n. Okay. Plus, the remainder of them is they have to be incremented for the remaining elements that need to be incremented one time. There's going to be a lot of errors because I didn't comment any of this out. How did I know? How pathetic. There's so many things in here I didn't even use. So funny. Just going to delete all this, guys. I apologize. This is very unprofessional. Whatever. I'm just going to delete all the comments now. 2223. All right. So were we able to just make this much faster? Yep, we were. Cool. So that's what's cool about walking through things too. You don't actually need to do anything. So what's the run in space complexity of this solution? You don't even need to do this. Look at this. Okay, I'm getting too. You can get too crazy, and it's like, oh, you erase more lines. It's like it gets crazy. Okay, so time. Well, constant time, constant operation, constant operation, constant operation. Rebuilding this array, I guess you could technically say it takes n time because you have to build the actual array of size n. So that's big O of n time to build the array. Space, also O of n because you have to build the array that you're going to return, right? So O of n, O of n. All right, guys, that's it for today. It's been a while since I made a video, so I'm a little bit rusty. Hopefully that made a little bit of sense. It's kind of hard for me to explain things as I'm doing them if I haven't already done them, right? So that's kind of what you saw probably within the first portion of this video, right? I'm just like trying to figure it out myself, and sometimes I feel like I distract myself by speaking out loud. But that's the skill set that you need in interviews. So I definitely recommend that as you work through problems, you're very vocal about what you're doing, because that's going to show the interviewer at least your mindset, right? And that you're a collaborative, communicative person. And I know as engineers that can be kind of hard, right? Because you know, we like working alone. We usually tend to be kind of individualistic kind of people who like, you know, peace, quiet. You know, nothing's weirder than a like code review with somebody, right? So anyways, hope you guys have a beautiful rest of your day. Bye bye.